Hello students, today we are going to develop some formulae to determine the root of an given equation by using Newton-Rapson method. Before start an example, there is one correction in previous example. X is equal to tan x by first position method or Newton-Rapson method. In example, I think I have taken root in the interval 1 to 2. Instead of that, take the interval 4 to 5 because make that correction and try to evaluate that example by using Newton-Rapson method. So this is one correction. Now today let us first example obtain and formula using Newton-Rapson method to find square root of given number. Find Newton-Rapson and a formula to obtain square root of a given number. Suppose we want to determine square root of number c, given number c, and suppose we assume the square root of this number is what? X. Then if you squaring on both sides, you will get x square is equal to c. So this implies f of x is equal to x square minus c. F of x is equal to x square minus c. So this is our given function. Now what is f dash x? F dash x is equal to twice x, and therefore what is the Newton-Rapson formula? Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So xn plus 1 is equal to xn minus f of xn. What is f of xn? In place of x, just put xn. It is xn square minus c divided by twice xn. So if you simplify this, you will get xn plus 1 is equal to twice xn square minus xn square minus c divided by twice xn. So xn plus 1 is equal to xn square minus c divided by twice xn. So this is the formula to find the square root of any given number c by using Newton-Rapson formula. Just assume initial root, and by using this formula you can find successive root x1, x2, x3 up to your correct root up to desired accuracy. Okay. Now next formula, obtain Newton-Rapson formula for r root of a given number. For r root of given number. There is cube root, fourth root, fifth root. So in general, we want to develop a Newton-Rapson formula to find an r root of a given number. That is, suppose we want to determine r root of a number c. R root of a number c. So we assume here it is equal to x. We assume here again the r root of c is what? X. So this implies x raised to r is equal to c. If you take the r power on both sides, you will get so if you take the r power on both sides, you will get xr is equal to c. So from this we can write our f of x is what? X raised to r minus c. So now to obtain to use a Newton-Rapson formula, we want to determine the value of f dash x. So f dash x is what? R x raised to r minus 1. Derivative of c is what? 0. So what is the formula of Newton-Rapson method? Xn plus 1 is equal to what? Xn minus f of xn divided by f dash of xn. So xn plus 1 is equal to xn. Xn is what? Xn as it is f of xn. So in place of x, just put xn. You will get xn raised to r minus c divided by f dash of xn. R xn r minus 1. Okay. In place of x, we put here xn. So r xn r minus 1. If you simplify this, you will get, just multiply this r xn r minus 1 to this side. You will get r xn r minus 1 and xn raised to 1. This 1 minus xn raised to r. Because of this minus sign, it will convert it to plus. This whole divided by r xn r minus 1. So xn plus 1 is equal to this plus minus 1 plus 1 become 1. So r xn r minus xn r plus c divided by r xn r minus 1. So next, if you simplify this, just take this xn r outside the bracket. So xn plus 1 is equal to xn r outside r minus 1 plus c, this whole divided by r xn r minus 1. And this is the formula to determine r root of any number. Okay. Now next by obtain the Newton-Rapson method to find inverse of a given number. Inverse of given number. Okay. Now, that is what is meant by inverse. What is the inverse of 2 under multiplication is what? 1 by 2. What is the inverse of 3 is what? 1 by 3. So similarly, if c is any given number, we want to determine a value of 1 by c by using Newton-Rapson method. So suppose we want to determine an inverse of a given number c. Then we assume here 1 by c is equal to x. Suppose the inverse of 1 by c is what? X. So what this implies, 1 upon x is equal to c. If we interchange the numerator and denominator, you will get 1 upon x is equal to c. So what this implies, f of x is equal to 1 upon x minus c. Okay, so this is our given function. Now, so what is f dash x? F dash x is equal to minus 1 upon x square. So what is the formula? Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So xn plus 1 is equal to xn minus f of xn. So 1 upon xn minus c divided by f dash of xn minus 1 upon xn square. So by using this minus sign, minus become plus. So xn plus 1 is equal to xn, and this a upon b divided by c upon d is what? You can convert. You can write this a upon b divided by c upon d. We can write this as a upon b into d by c. So we can write this as xn plus xn square 1 upon xn minus c and this whole divided by 1, but since denominator is 1, we cannot write the 1. It is obviously 1, so xn plus 1 is what xn. If you multiply this xn square outside, that is what xn, 1 xn will get cancelled here, and minus c. So what is xn plus 1? Xn plus 1 is equal to what? Xn plus 1 is equal to what? C, yes, correct here. One get 1 and here xn square. If you multiply this xn square inside the bracket, then 1 xn will get cancelled here and xn minus c xn square. So xn plus 1 is equal to twice xn minus c xn square. So this is the formula to find an inverse of any given number. Or if you simplify this, you will get, that is, putting this xn outside, you will get xn plus 1 is equal to xn 2 minus cxn. Okay, so this is the formula to find an inverse of any given number. So here we have finished our first chapter. Again, in this chapter, first we have seen the definition of error. Why error occurs? Because we cannot solve an error equation, or if there is an equation involving a transcendental equation, means what? Exponential function, trigonometric function, and logarithmic function, inverse function, then we cannot able to find a root of a given equation by using our as usual method. In that case, we want to apply numerical techniques, and while applying the numerical techniques, we will get an approximate root, not an exact root, but error is what? The error is very small or negligible. So that's why we have seen, that is, we are going to reduce our error by taking more iteration. Okay, so that's why we must understand what is the definition of error. Error is what? Difference between the exact value and approximate value. If you take it small, you will get an absolute error. Then next is relative error, percentage error. If you divide absolute value by true value, you will get the relative error, and if you multiply relative error by 100, you will get an percentage error. Then next we have seen a round-up procedure. Significant figures is there. Then rounding up process, you can round a given number to either significant figures or decimal places. Okay. After that, we have started bisection method. All these bisection method, regular false position method, iteration method, then Rapson method, they are all to determine an approximate root of a given equation. Now in bisection method, again location of root is very important. There is one theorem: if your function f is continuous, and one is positive, one is negative, then it must cut the x-axis, and where it cuts the x-axis, it is called an root of a given equation. That's why we are always taking one positive and one negative. That is, root always lies between an opposite number. Okay. Once you understand this, in bisection method, next iteration we find c is equal to a plus b divided by b, and in false position method we find a f of b minus b f of a divided by b minus f of b minus f of a. Next, iteration method. In iteration method, we rewrite our equation in the f of x as x is equal to phi of x, where we are selecting our phi of x such that mod of phi dash of x must be less than 1. Once you select your phi of x, select any approximate root lying in interval ab. Do remember this. आपल्याला हे लक्षात घ्यायला पाहिजे की ज्यावेळेस आपण इटरेशन मेथड आणि न्यूटन रॅप्सन मेथड अप्लाय करतो, त्यावेळेस फर्स्ट अप्रॉक्सिमेट रूट आपण सिलेक्ट करणार आहोत. कोणताही त्या इंटरवल मधला तुम्ही रूट अप्रॉक्सिमेट रूट सिलेक्ट करू शकता, किंवा तुमच्या एक्झाम मध्ये पण x0 काय घ्यायचं हे दिलेलं असतं. सो तिथपासून तुम्ही x0 स्टार्ट करू शकता, आणि नेक्स्ट यू कॅन फाइंड x1 बाय यूजिंग phi of x1 is equal to phi of x0, x2 is equal to phi of x1, and so on. Okay, and but if you observe the rate of convergence of iteration method is very slow, or even though the rate of convergence of bisection method, regular false position method, iteration method is very slow. To accelerate a given rate, That is what is meant by rate of convergence means what you require more than 10 iterations to get an error must be correct up to 2 decimal places. So in iteration method you can accelerate this process by using Arcane delta square process. Within a 2 or 3 steps you will get your an approximate root. Correct up to 3 to 4 decimal places. Now last is what Newton-Rapson method. Now Newton-Rapson method is again its rate of convergence is 2. Okay, is very fast. So as compared to previous 3 method, then you will get a root very close to an exact root by applying 3 to 4 iterations.